So this is where we used to have our wind inverters. So the two big wind inverters used to sit there. So what we've done, we've put cable tray and stuff in anyway. So we removed them. One was we were finding that we had, it takes about 20 watts per inverter to even really start. And that's just what will happen when you have to take anything. So we're producing DC volts, and then it has to go into inverter to produce AC volts, and then to go then through to our sunny inverters to do DC volts, then go back into batteries. So long story short, there's a lot of inefficiencies there, wasting energy where it doesn't need to. And you say, well, that's only 20 or 40 watts, don't worry about it. But the problem is that the way that our meters work, so they've all been reset now, you're just getting an inaccurate reading is one. Two is, why do I want to waste 20 or 40 watts? I'd rather be bottling 20 or 40 watts than no watts. Again, it's a similar kind of thing. Wait until you are off grid in the middle of winter, and you'll rather have anything than absolutely nothing. So again, just very simple. So just MC4 connectors. What we've got in there is a one-way. So these are just blocking diodes. I think they're good for about 30 amps. You can parallel them up and put more through it if needs be, but 30 amps should be enough. Might be something we want to revise. So, we still got like the PeaceFair data logger in place as and when we need it, but we hardly ever actually use it. We just go by what the actual other gauges are saying. So what is the interesting bit is that. Okay, so that's an over-under DC voltage relay, basically. So because now we're hooked directly into our lithium battery, so there's no massive problem here of trying to pump too many amps into it. That's fine. The problem is going to be, well, what happens if the batteries are full, sunny day, you're fully loaded and your battery's absolutely fine, and then the wind picks up, which we've had a few times. So you need a dump. So you still have, those are the original dumps. So, and that's a contactor off the Nissan Leaf battery pack anyway, so we've just put it to good use again. But what we've done is actually, if you follow the cabling that comes off it, round, in blue, then it goes up, and then round onto the two bus bars. So because there is basically another blocking diode in place here, what it will actually do is, if we get to a certain point, 57.8 volts, it will actually pull that contactor in, and so that any of the wind generation will just be dumped straight away to these two dump loads, which are look like fluorescent tubes when they light up, but they're just heaters. Like in the old days, you had the 3-bar heaters, okay? And that's basically it. So it's, hopefully we're suck and see, but at the moment it seems to be working absolutely fine. We've not had to change anything else. And interestingly, the smaller wind turbines, that's a 500 watt 5-blade. Well, it's brighter than I thought today. So that one actually is working significantly better. So, very possibly that's what it could be. So we've cleared up a lot of the AC gaps, so it's almost just all purely DC here now, going straight into the lithium batteries. But we'll test it. We'll see how that goes, and see if that has any problems. Okay.